Now, at this time, you will be getting a combined test of Chapter 4 and 5. As I mentioned, I gave a review of 4 already, so let's do one for 5. And I was just thinking that this might be specifically geared toward those people that may want to finish the course ahead of the official time and giving you a little review of what to expect. So with that in mind, we had some exponents first. And what can we say about this? Well, we're raising a negative value, a negative base, to an odd power. That indicates our answer will be negative. If it were to an even power, it would have been a positive. But right now, an odd power, it's negative. So it's just 2 to the third, negative 8. Now, if you're using your calculator for this, you have to put the base in parentheses to get that negative sign included. Because as we look at number 2, this is to a even power, but our base is only the 2. The negative is not included. So when we raise 2 to the 4th, we get 16. And then we apply the negative. So this is a good little review here initially to show you the difference between these two types. Now here we have a negative exponent, which just means we're going to take that 4, bring it down to our denominator, and as that 2, negative 2, crosses the division bar, the sign changes. So this becomes then a 1 over 4 squared is 16. Now here the key is use only positive exponents in your final answer. So the rule, we just multiply the numerical coefficients, get an 8, add our exponents, get an 8 also. Watching the signs, we're going to get a negative 20 x to the 11th. Now here we're going to subtract the smaller from the larger exponent and get a to the 3rd, b to the 3rd. And here a review of what we do with 0 exponent. All of this is our base to the 0 power. Anything to the 0 power is 1. A couple of things are going on in number 8, so let's take a look at that. Now here we have a negative exponent of a fraction. And we said the way to make that a positive is to take the reciprocal of what is inside. That is, flip this over, keep the same sign, and then change the negative 2 to a positive 2. So here we have a base of a negative 1/3 that is squared. Negative 3 times negative 3 is a 9. Now, in number 9, again, there's a couple of ways to do this, but one of the things would be to get rid of as much canceling as you can inside here before you start. So this is going to go up as a positive 3 up here. So this in my numerator gives me a positive 3. This gives me an x up here. This y comes down and gives me a y to the 4th. There's a 1 there. When it comes down, it subtracts from the 5, gives you a 4. That's still a negative 2 though. But again, now we can just flip it and get y to the 4th over x. We're just flipping that and then making our exponent a positive. So this then becomes y to the 8th over x to the 2nd. Now again, there are other ways to do it. You could have done all this multiplication first, then do the simplification. It comes out to that. Now for number 10, we're going to put this to some power of 10. And we're going to make this a number between 1 and 10. So there's 3, moving the decimal point 6. I move the decimal point 6 places, and I get 5.723. Scientific notation. Now in converting it, we want to have a number 7.94 that we need to move the decimal because it's negative. It's going to be a small number 6 places from where it is. So there's one place. So I'm going to add 5 zeros. 1, 2, 3, 4, 5. Place my decimal point now over 6 places. And then I add a 0 for good measure. And that's my answer. Now, for this one, they want an answer in scientific notation. So I'm first going to multiply the 2.4 times 3.8 gives me a 9.12. Again, that's a number between 1 and 10. So we're good there. And then we just add our exponents. 10 to the 8th. That's in scientific notation. Now, for number 13, find the degree of the following polynomial. Well, this one is 5. This one is 3. This one is 2. This one is 1. And this happens to be 0. So the degree of a polynomial is the highest degree of any one term, which is 5. Now, perform the indicated operation. Many techniques, you could do it horizontally, just remove the parentheses. When there's a plus between them, we want to combine like terms. I had suggested you do it vertically. Put these in their like term columns now. And now that they're in like term columns, just add them. So that's 6x squared, keeping in mind variables never change when we're just adding. And this is a negative 16x minus 9. Now again, we're looking for strategy here. And you're not going to have this many examples. There'll just be a few. So here again, line them up vertically. This with this, this with this, and this with that. Now I did this one just mentally. That gave me a 5x squared, a negative 7, negative 8, negative 15x, and a negative 9. Now here's where it gets to be a challenge when you're asked to subtract. Now what I would do here is I'd do my top, 5x squared minus 3x minus 5. Now that doesn't change. This is just taken out of the parenthesis. But when you have a negative in front of a parenthesis, which indicates subtraction, you do so by removing the parentheses and changing each of these to their opposite sign. So this is going to be a negative 7x squared. This is going to be a positive 4x. And this is going to be a negative 4. So remember to change each sign, like term columns, whether you do it horizontally or vertically, you get the same answer as long as you do it correctly. So here we get a negative 2. Here we get a positive 1, which we don't write. The variables don't change. This becomes a negative 9. Now here again, the technique is just to distribute that. And here we're going to FOIL. Here we have that special method of doing it. Here we're going to FOIL conjugates. This gives us a special thing. And here the technique for division is to put your denominator under each term and then sort of separate them and simplify. So let me do all of these. You might want to try it, and then I'll go over them with you to keep the tape a little short. So here our sign will be negative. 2 times 3 is 6, x to the 7th. Negative times negative, our sign is positive. 2 times 2 is 4, x to the 5th. Here our sign is negative. 2 times 4 is 8, x to the 3rd. Now here in the FOIL, this times this will be 6x squared. Now my outers are 9x. My inners are 10x, which leaves me with a negative x. And my last will be a negative 15. Now you could do it the traditional way of saying this times this, then negative 5 times this, but the FOIL is what we're shooting for. Now the special way of doing this one, recall, is to square this, multiply these two terms together, you get 6x, double it, and then square the last term. This is a perfect square trinomial that when you factor it goes to this. When you factor this, that goes in the next chapter, you go to that. Now these were conjugates. That when you multiply conjugates, it's the sum and the difference of the same terms. One has a plus, one has a minus. The middle terms cancel out. So this gives you 4x squared minus 25. These are special products that we talked about in our previous lessons. Now, when you have the difference of perfect squares, that will factor later into its conjugates. Now here we're just simplifying. This becomes x to the 3rd. Subtracting that, the 4's cancel out. Here we have a negative 4. 2 from 3 is just 1. And then here you have a negative. 4 goes into there twice. And the x cancels out completely. Now, if this didn't cancel, sometimes you have letters left in the denominator. Be sure they are in the denominator. And then we're going to do this long division. So, in number 22, this is how you set it up. Now, if there was a missing value, x to the third, x to the second, x to the first, x to the 0, that's perfect. If one of the values, the degrees were missing, you would have to put a 0 x squared in there to fill that spot, because to do it this way requires a certain sequencing. Now, 2x goes into this how many times? Well, we said you could use the little technique of 8x cubed divided by 2x. Well, 2 goes into there, 4. X goes into there, x squared. That's simplifying this to that, because now 2x times this gives you 8x to the third. Then we take our next value, negative 3 times this gives you a negative 12x squared. Now, the next stage is critical. What do they want us to do here? Well, they want us to subtract. Well, in algebra, we subtract by changing the signs and then adding. So these cancel out, give me a 0. This becomes a negative 4x squared. I bring down my 12x. Later I'll bring that down too. Now 2x goes into there, and you can do that same technique, a negative 2x times. Because when you do this multiplication, 2x times a negative 2x, you want to get exactly what you have there. Now, negative 3 times negative 2x is a positive 6x. Now again, this is critical. You're going to put a line, and that indicates you're going to do some subtraction, where you have to change the signs. And I should just erase that. And now we add. So this cancels out. This becomes 6x minus 4. We now will go 2x goes into there 3 times. 2x times 3 is 6x. That's what we want to have. And now this times this gives me a negative 9. I put my line, change my signs. This becomes a 0. This is a positive 5. And I have this as my answer, plus 5 over our divisor, 2x minus 3. And that's how you would write it in MATLAB. Okay? Now, why it's so important to show your work that if for some reason you had the correct answer here, and then when you put it into MATLAB, they said, well, you shouldn't have had a plus sign there or something. Your work supports it. We can give you that point. And that's why that is critical. Okay, we didn't do synthetic division or these others. So that will wind up this test, and hopefully is helpful for your chapter tests on 4-5, and then later your final exam. Good review for the final exam as well. And there are, I believe, 100 questions in your homework area that you could do as a review for your final exam. By doing it as homework, you get to do all of the practice, and the tutorial bars are there to help you as needed. Also, bring any questions you have into Math Lab. Myself or our tutor would be happy to help you. Good luck.